So the BC students, hopefully you found your way back over here for your answers to questions 5 and 6. In case you did not already watch the AB video, the answer to your question number 4 is on the AB video, because question 4 on the AB test was exactly the same as question 4 on the BC test. So I'm not going to rework it out on a separate video. You BC students are smart enough, you can go back, open the 2015 AB video for number 4, and watch the solution to number 4 there. So I'm going to begin this video with the solution to number 5. So question 5 says, we're given a function f of x equals 1 over x squared minus k times x, all right? And k is a non-zero constant. And then they go ahead and they give us the derivative of f of x. Not that we can't find the derivative, but they give us the derivative to save us the time of having to go through the work. So we get k minus 2x over x squared minus kx. So they gave us the derivative so we would not have to go through the quotient rule and find the derivative. And let's be honest, it eliminates the chance of us making a silly mistake. In part A, it says, let k equal 3. So our function becomes f of x equals 1 over x squared minus 3x. And it says, write the equation for the line tangent to the graph at the point whose x-coordinate is 4. So we want the equation of the tangent line when x equals 4. Now we know how to write the equation of the tangent line. That's y minus f of, in this case, 4 equals f prime, and x is going to be 4 here, times x minus 4. So this problem comes down to, can you plug a 4 into f, and can you plug a 4 into f prime? I mean, that's literally what the question comes down to. So what do we get if we put a 4 in here, right? What's f of 4? F of 4 is going to be 1 divided by 16 minus 12, or 1 over 4, right? And then f prime of 4, now remember, this is our formula for f prime, but for us, k is 3, right? K is 3. I didn't rewrite it. So this is going to be 3 minus 4, so that's going to be negative 1. And on the bottom, I'm going to have 16 minus 12, right? We already did that part here. 16 minus 12 is 4 squared, so we're going to get 4 squared. We're going to get negative 1/16. If I did my math right there, let's see. That's 3, oh wait, that's not right. 3 minus x is 3. So 3 minus 6, right? X is 4. Man, I just suddenly lost my brain. X is 4. So that's 3 minus 8. Wow, there we go. This is negative 5. My head was telling me I was doing something wrong. So there we go. Now we can just plug this in. This is going to be y minus 1/4 equals our slope, negative 5 over 16, times x minus 4, right? And that's the equation of our tangent line. That's it. We get full credit for that. That's the answer to part A. Part B goes on and it says, let k equal 4. Okay, so in part B, we're going to change it up now. Now k is 4, right? So now our function is 1 over x squared minus 4x. And maybe this time I should write down the derivative. If k is 4, that's going to be 4 minus 2x divided by x squared minus 4x squared. Right? Maybe I'll be able to do my math better now. Determine whether f has a relative min, a relative max, or neither when x equals 2. Justify your answer. Well, if this is going to be a relative max, the derivative has to either equal 0 or fail to exist. First and foremost, is x equal 2 even a critical number? That's the first thing we have to check. So we better find f prime of 2, right? Because if f prime of 2 equals 0, then this is indeed a critical number. Or if f prime of 2 fails to exist, it's a critical number. Well, what's f prime of 2? F prime of 2 is 4 minus 4 divided by, when we plug in a 2, we get down on the bottom, right? We get 2 squared, that's going to be 4, minus 8 squared, and we get 0. So 2 is actually a critical number. So that's an important first step. Now what do? We're going to run the sign test. Our critical number is 2. We're going to pick a value on both sides of 2 and see what happens. That's how we're going to determine this, right? What happens at 2? Does this function change signs? If it does, how does it change signs? Sorry, does the derivative of this function change signs? If it does, how does it change signs? Well, we've already, we're plugging in x is 2. So let's plug in x is 1, see what happens, right? What do we get for our derivative when we plug in x is 1? When we plug in 1, we get 4 minus 2, right? So my numerator, so I'm going to plug in 1. My numerator is positive. When I plug in, my denominator is going to be positive because it's squared, so the derivative is going to be positive there. What happens when we plug in 3, right? When x is 3, we're going to get 4 minus 6. My numerator is going to be negative. My denominator is going to be positive because I square it. I get a negative there. So my function is going, it's increasing, and now it's decreasing. So x equals 2 is a relative max because the sign of f prime changes from positive to negative at x equals 2. So x equals 2 is a relative max. Part C, right? Let me go ahead and erase. Well, I hate to erase some of this because a lot of times you need more of it. Part C says find the value for k for which f has a critical number at x equals negative 5. Find the value for k. And so we're not going to need this. Let's just go ahead and erase this. When x has a critical number at negative 5. So when will x have a critical number, right? Critical numbers occur where the derivative equals 0 or f prime fails to exist. Those are the two things we have to work for. So we take our derivative right here, right? That's our derivative, and it says find the value of k, right? Find the value of k. So we don't know k, so this is our derivative. Our derivative is k minus 2x. And we want that divided by x squared minus k x squared, right? We want this to be 0. When is this going to be 0? And they tell us the value of x, right? If x equals negative 5. Now, it could be the case that it's 0, or it could be the case that it fails to exist. Now, let's put in negative 5, and we get what? We get k plus 10, right? Now, this is going to be 25, right, minus k times 5, which is 5, right? X is negative 5, so that makes this minus k minus, that's plus 5k squared. And they want to know, when is this going to equal 0, right? What's a value for x that's going to make this equal to 0? Well, if we solve this, we can say, well, sorry, not a value of x, a value of k, we can see that the answer is going to be k equals negative 10. If k is negative 10, my derivative is going to be 0, and we're going to have a critical number at negative 5. Okay, so that's part C. Part D says, now we're going to let k be 6. Okay, so we've had k be 3, k be 4. Now we're going to let k be 6. So my function is going to be f of x equals 1 over x squared plus 6x, right? That's going to be my function. Find the partial fraction decomposition for the function f, and then use that to find the integral. All right, so this is a true BC question. We've got to find the partial fraction decomposition of this. So let me clear some space over here. It's been a while since we've done partial fractions, so this will be fun. So we know what to do, right? We know what to do. We're going to factor this, and so when we factor this, we're going to get 1 over x times x plus 6, right? And now we rewrite this. These are both linear, so we rewrite this as a over x plus b over x plus 6, right? That's what we do. And what do we know this is supposed to equal? Well, where are we going to go from here? Right, we're gonna get a common denominator like we've always done with our partial fractions. And so what is that gonna look like, right? This is gonna turn into, just looking at the numerator, of course, we're gonna have a times x plus 6 plus bx, and that numerator is gonna equal this numerator, which is 1. And so we're gonna let x equal 0. If x equals 0, the b term goes away, and we get what? If x equals 0, we get 6a equals 1, and that gets us a equals 1 over 6, right? A equals 1 over 6. Oh, goodness. I cheated before I started the problem, and I looked at the answer. So I know that's not supposed to be 1 over 6, and it's not supposed to be 1 over 6 because I wrote the function wrong. Typical Kevin Rainier mistake. So this is x minus 6. So this turns out to be negative 6, and this I would have found it. I know you guys were talking about it amongst yourselves, but there we go. A is negative 6. So now what are we going to do? We're going to let x equals 6, aren't we? And that's going to cause this term to go away, and we're going to get 6x equals 1, 6b equals 1, and that gets us b equals 1/6. So this function right here becomes a, which is negative 1/6 over x, right? Well, we'll change the way we're going to write it here in a second, plus b, which turns out to be 1/6 over x minus 6, not x plus 6. So what do we really have here, right? We really have negative 1/6 times 1 over x plus 1/6 times 1 over x minus 6, and that's our partial fraction decomposition, right? Now what do they want us to do? They want us to take the integral of that. Let's just call this g of x. So they want us to find the integral of g of x dx. So when we integrate this, we're going to get negative 1/6, the natural log, the absolute value of x, right? Negative 1/6, the absolute value of x. And over here, this is a 1, so we don't have to do a use of here. So we're going to get plus 1/6, the natural log, the absolute value of x minus 6 plus c. And, you know, we can leave our answer like that. We can put our answer together using log properties. We don't care. Right? We don't care. So that's the solution to problem number 5. Now we'll move on to question number 6. That'll complete our journey through the 2015 BC free response test. So what's going on in question 6? I don't know. Let's take a look. Oh, okay. So question 6 is a series question. It says the Maclaurin series for the function f is given by this, and they write it out for us. And they tell us it converges to f of x for the absolute value of x is less than r, where r is the radius of convergence. And they want us to find the ratio, the radius of convergence. It says use a ratio test. So that's something that we're going to cover on this year's AP exam. We can do the ratio test. Let's see part B. Write the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of f. Well, we could do that, right? We could do that. We could find the derivative of f, and then we could write the first 4 terms of that. That's something that we could do. Part C says write the first 4 non-zero terms for the Maclaurin series for e to the x. Now, the Maclaurin series has been removed from this year's test, so I'm only going to do part A here, right? Part A is the ratio test, and we know how to do the ratio test. So let's go ahead on number 6. We're just going to do part A. And so part A said, use the ratio test to find the radius of convergence. So we know the n, well, let's just write down our series. So we have the series n equals 1 to infinity, negative 3 to the n plus 1, n minus 1, over n, x to the n. Okay, so that's our series, and they want us to use the ratio test. So we know what we're going to do. We're going to take the n plus first term, we're going to divide it by the nth term, aren't we? And so what do we get here? Well, the n plus first term, that's going to be negative 3. We're going to add 1 here, so that's going to be the n, divided by n plus 1, and this is going to be times x to the n plus 1. Now, we're not going to divide, right? We're not going to divide. We're going to go ahead and take this, and we'll find the ratio, not by dividing, but by multiplying by the reciprocal. So what are we going to get? We're going to get n here, right? We're going to get n up here. This is going to be negative 3 to the n minus 1, because we're doing the nth term, right? And down here we're going to have x to the n, aren't we? So what is this going to reduce to, right? It's going to reduce to, well, we have a negative 3 to the n, we have negative 3 to the n minus 1. That leaves us a negative 3. We have x to the n plus 1 divided by, right, divided by x to the n. So that leaves us an x, right? And then what else do we have? We have n divided by n plus 1. So we have an n on the top, and we have an n plus 1 down below, don't we? So what are we left with here? We're left with negative 3n over n plus 1 all times x. That's our ratio. Now, what do we do for the ratio test? We take the limit of the absolute value as n goes to infinity. So we take the limit as n goes to infinity of the absolute value of this. We get negative 3n over n plus 1, right? All times x. But of course, x can come out, and we're left with the leading coefficients are going to be our answer, because we have the same degree in the numerator as we have in the denominator, and so we're left with the absolute value of negative 3, which turns out to be 3, and of course we can't evaluate the absolute value of x, so we get 3 times the absolute value of x. Now, we know this converges, right? We know this converges when 3 times the absolute value of x is less than 1, and what does that get us? That gets us, by division, the absolute value of x is less than 1/3, and so our radius of convergence is, right, we converge from negative 1/3 is less than x is less than 1/3, so our radius of convergence is 1/3. All right, so that's the answer to part A. Part B and part C don't really apply to this year's test, so this is where we're going to stop the video for the 2015 test. All right, keep working hard.